Welcome back to another video, and in this video we're going to be continuing on with our UIKit tutorial series, and in this particular tutorial we are going to be concluding our videos on network requests with Swift by talking about patch requests. Now, patch requests are a kind of network request using HTTP that allows us to send data to our server in little bits and pieces to update specific parts of a record or resource on the server, right? So patch is very similar to put. Put you'll find as well online and stuff like that when you're talking about HTTP requests. So put is like I said, it's similar to patch, except put is what you would use semantically to update an entire record or resource. Patch is exactly what it sounds like. It patches certain parts of a record or resource. So it doesn't update the entire thing, but updates only certain parts. Now, again, you could swap put in patch. And it'll work all the same, but of course, if you want to, conform to REST, if you want to keep with those rough standards, those rough guidelines, then post is obviously for creating, get is for getting records, delete is for deleting records. Patch, update certain parts of a record, and put, you would update the entire record. All right. So let's go ahead and go into Xcode, and we'll write the networking code necessary to send this patch request to our third-party API. Now, the endpoint that we're going to be working with today is HTTP localhost 8080/API/projects/update-status/ whatever the ID is for the project we want to update. And then in the request body, we're going to send an update to the to whether or not the project is closed, right? That's what we mean by status. So is the project currently active or is it closed? So inside of our network manager, I have a new method written out called update status. And we take in a project as well as the new status for that project. Now, if you properly follow naming convention in Swift, the method should read like I have it here. It should read out really easily like English. But it's not necessarily required to follow Swift coding standards. It is a good idea, though, to make it easier on other developers. So inside of this method, the first thing we need to do is we need to specify the URL endpoint that we want to send our request to. So just like every other request, we'll say guard let URL equals URL string http://localhost 8080/API/project/update-status/ and then we will use string interpolation to put the ID for our project in here. So project .id. Then we will have else return. All right. So now that we have our URL, we need to decode, or rather not decode, we need to encode some, we need to encode a Swift object. Now, what object do we need to encode? We shouldn't encode an entire project here, right? And that is true. So what I have in my code base now is I have a model called patch project. This model also conforms to identifiable. And, okay. It doesn't conform to identifiable, but what it does do is it conforms to encodable. So we can encode the data from this object, but we can't decode anything. And that is because this is only meant for patch requests when we send the data. We don't need to decode a patch request body on the client. So what we'll do here is we'll say let patch project equals patch project patch project, and we want to pass it one parameter because it only has one parameter, and that being the new value to send to the server. And we simply pass it new status. So the new status parameter of our update status method will be the is closed parameter of our patch project object. Next, we need to define our JSON encoder. So let encoder equals JSON encoder. And then we need to actually encode our JSON object. Or we need to encode our Swift object to a JSON data object. So we'll say let data equals try encoder dot encode, pass it patch project, and so this will encode returns a data object, and we are storing that in our data constant here. And then it's this data object that we send to the server. Our next task is to create the URL request. So var request equals URL request. We pass it a URL. Then we need to set the request body and its HTTP method as well as the content type. So request.http method equals patch request.http body equals data. And then request.setValue application/JSON. And then what header we want to use for this value, which will be content-type. All right. So let's go through what we just did here, just so I can catch you up if you're unfamiliar with what we just did. So what we did was we defined the URL that we want to send our request to. We created our JSON encoder. We encoded our Swift object patch project to a data object that contains our JSON that we want to send to the server. Then we created a URL request object, which contains all the information for our network request. We give it the URL in its initializer. We set its HTTP method to patch. So whatever our whatever kind of request we want to send is what the HTTP method property is. So we set it to patch because we want to set a patch request. Then we set the body of our HTTP request using HTTP body. We assigned that our data object. And then finally, we set the value for the content type HTTP request header to application/JSON so our server can process the request properly. And with that being done, we can now move on to the last two steps of our request, and that is to actually send the request to the server using URL session and to check the status code to make sure that everything went okay. Now, why do we need to check the status code? Well, we need to check the status code because not every issue that happens with a network request happens on the client, right? So not every issue is going to throw an error when we actually send the network request. Sometimes it's going to be a server-specific thing. So when it responds back, it could return a undesirable status code that signifies some kind of error on the server. And if that's the case, if it's not a status code that you expect for a successful request, then you need to let the user know that something went wrong. Otherwise, the user's going to think everything's okay, and if it's not, they're going to be really mad, right? They're not going to have a very good experience. So that is why we need to check the status code. So let's go ahead and send that request to the server. And we can do that by saying let _response. Right. So this tuple takes in two different values. We're using a concept called destructuring. The first value that we get back from our URL session .shared.data call is the data in the response. And we don't want that for a patch request response, so we use an underscore to ignore it. But we do want the response because we need to use the response to get the status code. We'll set this equal to try await URL session .shared.data for our request. And there we go. Now, one thing that I do want to do before we go and check the status code is I want to add another case to our network error. So up above our network manager, I have an enum called network error. It conforms to error, so it's a custom error. And we have three cases here. Right? So I did this ahead of time. I'm going over this with you so you have an idea of what we're working with here. So the first one is creation failed. That network error is thrown whenever there's some kind of undesirable status code when trying to create an object on the server. The second is for the deletion failed or delete failed. Delete failed is thrown when a delete request was unsuccessful. Then the update status failed, or status update failed, rather. This will be thrown when we get an undesirable status code for our patch requests response. Okay, so with that, we can go back into our update status method. And we'll say if let HTTP response equals response as HTTP URL response, then we can get the status code. So our response object that we get from our URL session, that is a URL response object. That does not inherently contain a status code. So we need to cast that to an HTTP URL response object, which does contain a status code. Because not all URL responses are going to be done over HTTP. Maybe they're done through FTP or something like that, right? So you are going to, you're going to want to make sure that we have HTTP URL response as our result here in this if let. And if that does succeed, we will have access to our status code by saying if HTTP response equals, or HTTP response dot status code is not equal to it should be, just to be safe, we'll say 200, which is an OK response, or HTTP response dot status code is not equal to 204, which is a no content response. So 200 is OK, meaning everything went good. And then 204 is also a successful request status code, which means no content, so there's nothing that we get back from it. All right, so if we don't get either 200 or 204, then we want to throw network error dot status update failed. There we go. And then before we throw the error, I also want, you can also print the HTTP response dot status code. This is useful for debugging. So if something on your server isn't right, or if you don't format your request properly, then you'll get a different status code. And you can then in your Xcode console see what the status code was to get a better idea of what you're dealing with. So we can save that, and that is it for our networking code. Now we need to actually use it in our UI. All right. So here I have a method called toggle status. Now this method is going to be called by a swipe action on each cell of our table view whenever we have a project inside of it. And as the name implies, this when this swipe action is toggled, or when it's tapped, it will go and toggle the project's status and update the UI accordingly. So let's go ahead and actually implement this. So the first thing is we're going to need the new status. So we can say let new status equals project dot is closed, and we do want to invert that. So we'll put an exclamation point in there. So let new status equals exclamation point project dot is closed. All right, so now that we have our new status that we're going to be working with, we should surround this with a task. Now inside of our task, after we have specified our the new status for our project, we need to say do, and then have a catch. And here we'll say print error localized description, and then we'll call completion handler with false. All right. So just calling completion handler with false will tell UIKit, hey, this action was unsuccessful. But inside of our do statement, the first thing we want to do is we want to attempt our patch request. So we'll say try await network manager dot shared dot update status of, and then we need to pass it project with new status, like that. And that's our network call, but we're not done. If we reach this point, then we know for a fact that our network request succeeded. And so now we can actually go about updating the UI. And the first thing that we need, right, is we need to actually update we need to now update the project in the array. So we'll say if let project equals self.projects dot or if let index equals self dot projects dot first index of our project that we got passed in. Here we can say self dot projects dot remove at index and then I will say let project equals self projects at the given index that we got here. We'll remove it from our array. Then we will say project dot is closed dot is closed dot toggle, and then we'll say self projects dot append project. And then we need to reassign the projects array. So we'll say self dot projects equals self dot projects dot filter $0 dot is closed is equal to the show closed variable from our controller. And then we want to sort it dot sorted $0 dot name is less than $1 dot name. Right. So why am I doing this in particular? Well, the first thing is that primarily, one, we need to make sure that when we reassign our projects, that it filters them based on the tab again, because we do this initially when the view loads, like after the view loaded. But when we reinsert the project, it's not going to do that filter automatically. So we have to filter it again ourselves. And then initially, after InView did load, we are also sorting the projects by their titles in ascending order. But when we append a new project, again, it's not going to sort by default on its own automatically. So we have to do that ourselves as well after the patch request. And that's what we're doing here. So we're making sure that everything is filtered properly and everything is sorted as necessary. And then the final step is to apply a new snapshot to let the data source know, hey, you need to update. Do your thing. Let's see. Oh, that's right. This should be a var. There we go. All right, let's go ahead and save our code and run it. Actually, before I do that, what I should do is we also need to call completion handler. And pass it true. So UIKit knows, hey, this action was in fact successful. And then the last thing we need to do okay, so we already have that being called. That's good. And we should be okay now. So let's go ahead and run our code. Just in your swipe action, make sure that you actually call the method that we have. So that way it actually works. All right. So we have one project here, test project 2, in our active projects tab. So let's go ahead and say close project. Theoretically, it's supposed to work. If we quit and rerun it, you can see it did work. It's just the UI didn't update properly like it was supposed to. But really, that wasn't the point. That wasn't the point of the video in the first place. For it to, for the UI to update properly. The point was to successfully demonstrate a patch request, which we have done. If we go into our terminal, you can see in our server's log output, you can see that it did detect our patch request and it handled it. So if we go back then to our app, we get inside of our closed projects here, we have project 1 and project 2. Now we can go back over and identify where we might have gone wrong with our UI updates. So let's quickly go over that and see if we can debug what happened. All right. Okay. So here we have our toggle status method. First thing we're doing is we're creating a task and saying, okay, let's create that new status, which does work, as we saw. We successfully send the network request. And then this is probably where things start going wrong. So we're retrieving the index of the project that we want to work with. We're getting the project from the given index. We are removing the project at that index. We're toggling the Boolean is closed on the project that we just created for our project. We're appending the project back onto the array. We are filtering and sorting that array, and we're trying to apply a snapshot. But as we saw, the UI update didn't work. Right? So somewhere in there is where the UI somewhere in there is where the UI failed to update properly. To keep this video short, I'm not even going to attempt to fix it, because it'll take some debugging sessions to get that to work. But you get the idea of how we can send a patch request. It does work. It's just the UI wasn't updating properly. That's entirely on me. But that pretty much does it for this video on patch requests. Thank you all so very much for watching, and we'll see you in the next video.